This idea of calculating the signed area is the idea of this section. Remember, signed area simply is the area between the x-axis and the line or curve that we're dealing with. If the curve is under the x-axis, this area gets counted as a negative. If the curve is above the x-axis, this area gets counted as a positive. The goal of this section is to be able to calculate the signed area of a function over a closed interval. Again, the signed area is referring to the area between the graph of the function and the x-axis. And it can be positive or negative depending on whether it's above or below the x-axis. Let's do an example of finding the signed area of a function on a closed interval. We take the function f of x equals 2x minus 1 on the interval from 0 to 3. That means from x values between 0 and 3. I have graphed f of x equals 2x minus 1 in Desmos. As you can see here, between an x value of 0 and an x value of 3, certain parts of the line are above the x-axis and certain parts are below. If I were to draw this, I would shade in this triangle here. So I would shade in this triangle. And then that triangle, since that part of the curve is underneath the x-axis, this triangle would count as a negative. And the triangle that goes all the way up to 3 from that corner, this triangle would be counted as a positive. So we'd have these two triangles going on. Now, I'm going to do this using geometry. I'm going to calculate the two triangle areas using geometry. Before I do that, I am going to do something where I change the look of this so that it looks like I've shaded it in. I've went ahead and rewrote my graphs so that we're using inequalities and you can better see the shaded region. Obviously, the shaded region above the x-axis goes from 0.5 to 3 on the x values. And in y values, it goes from 0 to a height of 5. This is a triangle, so I can use the formula for the area of a triangle to calculate this signed area. And then I can also use the triangle formula to calculate this signed area. This signed area, x value wise, goes from 0 to 3, and y value goes from 0 to -1. In terms of which triangle we're going to call the first triangle, I will call the first triangle the one that we have in light green. So the little one that is underneath the x-axis. The first triangle is going to have area of 1/2 base times height. Now the base times height in this case Doesn't matter which one you call the base and which one you call the height, but I'm going to call the base 1/2 because you go from 0 to 1/2. And I'll call the height 1 because we go from 0 to -1. When you calculate the area of that small triangle, you get an area of 1/4 of a unit, or 0.25 of a unit. The second triangle is going to be the bigger triangle, the one I had shaded in blue. The area of that is 1/2 base times height. The base in this case goes from 0.5 to 3. So the base is length 2.5, or you could write that as a fraction as well. The height goes from 0 to 5, therefore the height is 5. If you plug that into your calculator, 1/2 times 2.5 times 5 gives you, well, the same thing as 2.5 times 2.5, which is 6.25, or in other words, 6 1/4. This means since the second triangle was above the x-axis and the first triangle was below the x-axis, the signed area would be equal to 6.25 minus 1/4. So the total signed area is 6. That's what we're doing here. We have a total signed area of 6. If you remember how this question was phrased in the beginning, all we had was a function and a closed interval. Namely, we wanted to find the signed area of this function, 2x minus 1, on the interval from 0 to 3. We obviously did that utilizing techniques of geometry. I would like you to pause the video and try this problem on your own. Signed area of g of x equals -1/2 x plus 2 on the interval from 0 to 7. In the next video, we will show you how to do that.